Let's talk now about reactions involving ionization of a base. And by base here we mean the Bronsted definition of a base where, what's the Bronsted-Lowry definition of an acid-base reaction? It's a proton transfer, right? So if a base picks up a proton from a water molecule, okay, then what does it lead to? That gives you BH plus if B is neutral. And what's left behind from the water? Hydroxide, right? So a base in the Bronsted-Lowry definition is a proton acceptor. And when that base happens to accept a proton from water, it leads to the production of hydroxide, which would explain the increase in the hydroxide concentration if you put it in water. Okay? So the equilibrium constant for this type of reaction, where you have something that pulls a proton away from water to give you its conjugate acid and a hydroxide ion, the equilibrium constant for that is known as the Kb of that something, in this case, the base. Okay? So in this example right here, ammonia plus water. So your ammonia pulls a proton away from a water molecule, gives you ammonium ion and hydroxide ion. So the KEQ for this is called the Kb of NH3. Okay? So in general, when you're talking about base ionization, okay, when we're talking about a reaction whose equilibrium constant is called Kb, you're talking about a reaction between the base and water leading to the formation of its conjugate acid and hydroxide. So the conjugate acid of something will just be that something with the H plus with the proton attached to it. Okay? So ammonia with a proton attached to it would be ammonium ion. This is the conjugate base, conjugate acid of NH3. So we say that in a base ionization, the water is behaving like an acid. The water is donating the proton to the other molecule, or to the ion. Okay? So what is the conjugate acid of HCO3 minus? A base is a proton acceptor. So when this base picks up a proton, what do you get? You get H2CO3. Okay? And what you get is the conjugate acid. Okay? If something accepts a proton from something else, if it accepts a proton, it forms its conjugate acid. It's behaving like a base. So what would be the reaction where the KEQ is called the Kb of HCO3 minus? So we're talking about a reaction where HCO3 minus reacts with water, and what's it doing? Since it's behaving like a base, it must be what? Accepting a proton from water. So what happens when HCO3 minus accepts a proton? It becomes H2CO3, right? And what's left behind from the water? Hydroxide. So this is the reaction we are referring to if we're talking about an equilibrium constant known as the K sub B or Kb of HCO3 minus. That's the reaction of HCO3 minus with water where it pulls a proton away from a water molecule. What would be the expression for Kb here? If I were to ask you, what is Kb of bicarbonate ion? What would go in the numerator? Concentration of H2CO3 times concentration of hydroxide, and in your denominator, concentration of HCO3 minus. What's the activity of liquid water? 1. Okay.